Okay, hi guys. Back to this variation problem that we were working on. Like I said, a direct variation, instead of y equals mx plus b, it's just y equals mx. It always goes through the origin, always, always. So when they tell me we have a direct variation, I know it goes through the origin. Use x and y to find the constant of variation. The constant of variation is what they call the slope. All right, so sometimes you'll see it written this way, y equals kx. Sometimes I'd like to just still write it y equals mx, but just to stress that this is the constant of variation. This is how the x and y are always changing in relationship with each other. Okay, so I already found it. The constant of variation is negative 2/3. And the way I could do that is because I had this other point. They told me negative 3, 2, and then I know 0, 0 because it's a direct variation, and then I just counted. You can count up 2 to the left 3. That would be positive over negative 3. You can count down 2 and to the right 3, negative 2 over positive 3. Either way, it's negative 2/3. Excuse me. Okay, and then the equation of the line is y equals negative 2/3 x. Now I can see that it has a negative slope because the line's falling from left to right. Okay, so sometimes they don't just say it's a direct variation. They'll say something like y varies directly with x. As soon as I see that, guys, I write y equals kx. Or y equals mx, whatever you want. Okay, I'm going to use k right now because I notice they're using k over here. You have to get used to all the different terminology. As long as you understand what it means, then it doesn't matter if it's k or m or a or whatever it is. Okay, to find the constant of variation, I'm simply going to stick 14 in for y and 2 in for x. So I have 14 equals k times 2. Divide both sides by 2, I get k equals 7. So the equation is y equals 7x. That's my direct variation. Remember, direct variation is y equals something x. All right. I use these numbers that they told me, 14 for y, 2 for x. And I use that to find k, and then I rewrote the equation using this k value. Okay. K varies directly with J. Oh, why would they say that? Okay. K varies directly with J. So K equals, I'm going to have to use a different letter. K equals MJ. All right, whatever. When they say K varies directly with J, they mean there's a number that I can always multiply by J and get K. They're telling me that K is negative 8 when J is 6. So that tells me that M is negative 8 over 6. I'm going to reduce that and say that my constant of variation, I'm going to cut them both in half, is negative 4/3. Okay? So K varies directly with J. All right, just ignore what that I just said. K is sometimes used as the constant of variation. In this case, they're using K where they would use Y. You know, you have to understand that this letter varies directly with this letter. That means this letter equals something times J. So K equals MJ. I put negative 8 where the K was. I put 6 where the J was. M equals negative 8/6, which is negative 4/3. The equation then that relates J and K, J equals negative 4/3. Oops, I'm sorry. I said it backwards. It's K varies directly with J. Right? I have to read it in the right. K varies directly with J. So K equals something times J. I just found that something. It's negative 4/3. Okay, the first letter goes first, varies directly with J. So K equals negative 4/3 times J. Be careful with this, putting the letters in different places. You really have to keep it straight with in your head. Okay, the third is kind of a real life application. Again, this is applications of linear equations. The number of pages a student can read, we're going to call that P, varies directly with the amount of time spent reading, and we're going to call that T. A lot of times they use the letters that go with, what we're using. Time, let's call time T. Number of pages, let's call that P. But I see P varies directly with T. So P equals something times T. That's what that means when I see varies directly. Now I know the student can read 90 pages in 60 minutes. So I'm going to put 90 in for P and 60 minutes in for T, so that I can find that number, that K number, that constant of variation, or the slope. I'm going to divide both sides by 60. And let's see, if I divide that by 10, I get 9 over 6. If I divide that by 3, 3 over 2. We want to reduce it. Okay? So my final equation is P equals 3/2 T. So now you tell me the time, you tell me the pages, tell me anything. I know I'll be able to tell you the other variable. We wrote the equation. Now we're going to predict the number of pages a student can read in 90 minutes. Well, it'll be 3/2 times 90. Okay, so on your calculator, if you take 3/2 times 90, you get 135 pages. Okay, so in an hour and a half, so maybe, once I understand my rate of reading, that will help me judge how long it's going to take me. If I have an English assignment and I'm supposed to read so many pages, I'm like, how long is that going to take me? If I know this is kind of my rate, then I can figure that out. Okay? So it's nice to be able to do that. All right. That is it for your notes. I will be seeing you in class. Please do the assignments on Schoology. All right? See you in class. Have a safe, healthy week.